the first part of this assignment, very straightforward. We just learned in the past assignment that you have your position. That's the original function. X of t, we'll call it, sometimes called s of t. Take its derivative, that's velocity. That's the rate of change. Velocity is the rate of change of that. Acceleration is the derivative of velocity. That's the rate of change of the rate of change, right? So if you step on the gas pedal, you speed up. Speed is already your rate of change. Step on the gas pedal, you've now changed that speed. What is speed, though, exactly? So velocity tells us direction. Negative, we go to the left. Positive, we go to the right. Or negative, we go backward. Positive, we go forward. But speed doesn't matter what direction we're going in, so it's the absolute value of velocity. It kind of changed things up for us, made things a little bit more difficult. And we learned in the last one, looking at the graph, things are a little bit backwards. Even though it looks like velocity is decreasing here, the speed would actually be increasing, only when it's under the x-axis, though. When velocity increased, speed was increasing. When velocity was decreasing, speed was decreasing, just like you would think it would do. But when we're under the x-axis, it's a little bit backwards. So that being said, for speed, if your velocity is positive and your acceleration is positive, you are speeding up. If your velocity is positive but your acceleration is negative, you're slowing down. And if you were to look at this is really the only weird part of this assignment. Everything else will be straightforward, I'm telling you. So think about that. When our velocity was positive right here, we're speeding up when acceleration was positive, when the slope of this was positive. We're slowing down, the slope of this is negative. That makes sense. But if velocity is negative and your acceleration is positive, you're actually slowing down. It's backwards for negative velocity. And if your velocity is negative and your acceleration is negative, you're speeding up. Think about this. Two negatives makes a positive, just like you see over here. Two positives make a positive negative makes a negative, and a negative positive makes a negative. So it's similar to the whole multiplying numbers here. That's a quick way you can remember that, is two positives makes a positive, two negatives makes a positive. Just remembering that would actually be quite easy way to remember this. And then if you have a negative and a positive, then it's going to be negative, meaning slowing down. So let's take a look at this assignment. It's not too bad. What is the particle's velocity at t equals 2? So we're given our position function. Like I told you, sometimes they use x of t. Here they are using x of t, because they're talking about it moving along the x-axis. Kind of strange to think about that. And so for velocity, it's the first derivative of x of t, right? So velocity equals x prime of t, which is 3x squared minus 6, not x, it's t now, right? Minus 6t minus 9. So we want v of 2. So v of 2 equals 3 times 2 squared minus 6 times 2 minus 9, which is 12 minus 9, which is negative 9. So our velocity is negative 9. Now, because our velocity is negative, remember that means that our particle is moving to the left. If it was positive, it would move to the right. Pretty simple assignment, right? So look at this one. A particle moves along the x-axis. This time they're asking for velocity and acceleration, and now we're coming in with that speeding up, slowing down. So if they're both positive or both negative, speeding up. That's what we just went over up here. So if the signs are the same, then speeding up. So let's take a look. So this time they're starting with a velocity. That's kind of nice. So we already started with that first derivative. So v of t is t cubed minus 8t plus 16. v of 3 equals 3 cubed minus 8 times 3 plus 16, which is 27 minus 24 plus 16, which is 3 plus 16 is 19. All right. Then acceleration is going to be the derivative of velocity, which will be 3t squared minus 8. So a of 3 Notice we're checking at the spot 3 for both of them. It's got to be at the same spot. Kind of crazy to get the same exact number out. That doesn't usually happen. I'm actually kind of surprised. I want to double check that. Oh, well, okay. I used squared, or cubed, it was squared. I'm gonna say that was kind of strange. Okay, this changes our answers a bit. So our derivative will be 2t minus 8, which is 2 times 3 minus 8, which is 6 minus 8, which is negative 2. Crazy that one difference made that change there. And then 9 minus 24 plus 16 is going to be negative 8 plus 9 is 1. And since one's positive, one's negative, they don't match, the signs don't match, so we're slowing down.